We begin our study of dividing fractions by looking at what reciprocals are. The reciprocal of 3/4 turns out to be the fraction 4/3. Basically, we've flipped the fraction over. If I have a whole number such as 8 and I need to find its reciprocal, 8 over 1 flips over, so to speak, to become 1 over 8. The reciprocal of any number is 1 over that number. Now 1 over 3/4 is 4/3, as we'll see later when we talk about complex fractions. The only number that doesn't have a reciprocal is 0, because if you write this as 1 over 0, that is going to be undefined. If you remember, whenever the 0 is in the denominator, we use the word undefined to describe that fraction. It's okay to have 0 in the numerator over 1 because that fraction is equal to 0. It's only 0 in the denominator. We're not allowed to divide by 0, in which case we need to use the word undefined. When you are dividing fractions, you are not allowed to cancel across a division sign. All division problems need to be turned into multiplication problems, and we do that by multiplying by the reciprocal of the second fraction. So this problem is going to become 4/3 times 2 over 1. When you change that division problem into a multiplication problem, this second fraction gets flipped over. That's my little flip it over symbol. Now notice there's no way to cancel on diagonals. We're just going to multiply straight across and get 8 in the numerator and 3 in the denominator. Now I'm going to leave this as an improper fraction. There's no reason to convert that into a mixed number. The problem didn't begin with mixed numbers, and as you move on to your algebra classes, you'd prefer not to. Only convert that to a mixed number if the directions specifically tell you to do so. Let's do another. Let's say we have 5/3 being divided by 1/8. We can't have it in this form. We need to change this to multiplication by the reciprocal of 1/8, and so we would write this as 5/3 times 8 over 1. 5 times 8 in the numerator gives us 40, and 3 times 1 is 3 in the denominator. And again, I'm going to leave this as an improper fraction. Let's say we have a problem in which there's both division and multiplication. Remember that these are equally important under the order of operations, and we do whichever one shows up first, which in this case is the division. We're going to change this into multiplication of the reciprocal, and this will become 3/5 times 3 over 1. Then I will bring down our multiplication of 1/2. Now I could just multiply these, take the answer and multiply by 1/2, but when everything is just multiplication, I can just multiply straight across my numerators, nothing is cancelable here, and get 3 times 3 times 1 is 9, and 5 times 1 times 2 is 10, and find my answer to this problem in this manner. Now let's divide a couple of mixed numbers. You cannot divide mixed numbers as they are. You need to convert them first into improper fractions. So I'm going to take this 4 times 3, make it 12, plus 1. Rewrite that first mixed number as 13 over 4. The second one, 2 times 2 is 4, plus 1 is 5. I'm going to divide that by 5/2. And now I'm going to change this into multiplication by the reciprocal. So 13 over 4 is going to get multiplied by 2/5. Now I see on a diagonal I can cancel the 4 and the 2. They are both even. 4 divided by 2 is 2. 2 divided by 2 is 1. And now I can multiply across and get 13 over 10. This time, because I began with mixed numbers, I'm going to finish with mixed numbers. 10 goes into 13 one time, so I'm going to write that as 1. There are 3 left over, and so there will be 3 remaining over the 10, and that would be my quotient. Remember, the answer to a division problem is known as the quotient. Now let's try a word problem. A tailor needs 1 2/3 yards of fabric to make a shirt. How many shirts can be made from 21.5 yards of fabric? Now you know this is going to be a division problem because the section here is called dividing fractions. But if you weren't in this section and at the end of the chapter and you had to decide which operation to choose, this can be a little bit confusing. I would recommend changing the numbers. Pretend that it takes 2 yards of fabric to make a shirt and you've got 20 yards. 2 yards goes into 20 10 times. Oh, you can make 10 shirts. 20 divided by 2 makes 10. Ah, we're dividing. And then we can go backwards and do this division. Take 21 and 1/2 and then divide it by 1 2/3. Again, we need to write these as improper fractions. 2 times 21 is 42, plus 1 is 43. We're going to have 43 halves. And then I'm going to write this as multiplication, and when I convert this to the improper fraction, I will find the reciprocal automatically. 3 times 1 is 3, plus 2 is 5, so this would be 5/3, but I'm going to multiply by 3/5. Now, 3 and 2 can't cancel, 43 and 5 can't cancel, we can't cancel straight up and down. Okay, we have what we have. Multiplying across, in the numerator we're going to get 129, and in the denominator 2 times 5 is 10. I understand you might need to go off to the side to some scratch paper and go 43 times 3 and get your answer that way. Now, how many shirts can be made? Well, that means we need to reduce this to get an answer out of it. Well, 10 goes into 120 12 times with 9 left over, and so we'd have 12 9/10 shirts. Normally when rounding, we want to round up in this case because 9/10 is close to a whole, but we really can't make that 13th shirt with a fraction of the fabric. So only 12 full shirts can be made from this amount of fabric.